Now, another way we could look at these functions and looking at their behavior as x approaches a point, that is the limit, is to examine what happens on the graph and see what happens to the function. And here we go. We've got a function, nice one, y equals 0.5 plus 1, which is a function that has a slope of 1/2 and y-intercept at 0, 1. We want to know how would we characterize the behavior of this graph as x approaches 4. So here's 4. Right? And it looks like certainly at that point 4, y is equal to 3, and we could certainly substitute in 4. But we're not interested in what happens at 4. We're interested in what happens as x approaches 4. Right? What happens to the values of y as x gets to 4? And this gets to the nature of what a limit is. A limit actually describes what happens to the y values as x approaches. It's more dynamic. It's not asking what happens at x equals 4. We're asking what happens when we get near 4. So let's figure that out. It looks like as we approach values that come from, let's say, the left, values that are slightly less than 2, the y values look like they get closer and closer to 3, right? So as x is approaching 4 from the left, we're going to approach 4 from the left. It looks like the y values are going to approach 3. And let's do this from the right-hand side, right? So let's pick some values that are to the right of 4. And what happens to the y values as x attains values that are closer and closer to 4, this time from the right? And so we approach 4 from the right. What could we say? Well, it looks like the values of y also approach 3. And it looks like what we're really saying is that as x approaches 4, both from the left and the right-hand side, y approaches 3. And so we would characterize, perhaps we could characterize this as saying that this is the kind of function that as x approaches 4 from the left and the right, y approaches 3. Now, I mean, spelling that out, this might take a little bit of doing right here, but we could do that. Let's go ahead and just type it out. What does this all say? Oh, here, let me put a little text box so we could type this in. What it's saying is that as x approaches 4 from the left and right-hand sides, the y value approaches 3. This is what we might say about its behavior, which is very interesting. I mean, even though we don't really usually approach functions that way, we usually have been looking at them as values at a single point. This would be a good way of approaching this. So we're going to need some more formal definitions right here. And so what we're going to do is that we're going to use this notation right here. This notation is red. As we let x approach a certain value c along the x-axis, we would write that the limit as x approaches c of f of x is equal to our limit L. So in this particular case, if we were to write this out, we should write in our proper notation that the limit as x approaches, we use a little arrow, 4 of the function 0.5x plus 1, that limit approaches 3. Well, we're actually going to say equals 3, even though we're talking about the behavior. So the behavior is that the y value approaches 3, so that is the value of our limit. So this value represents a behavior and not the value of the function at that point. And that's an important thing to realize as we go into the next